let's get going here. So last week we learned about two different kinds of rules, right? We learned about the trapezoid rule, or the trapezoidal rule. And for the trapezoidal rule, what we did was we took our curve and the area under our curve, and instead of making rectangles and having to decide which side of the subinterval we use to determine the height of the rectangle, we just made our little subintervals into trapezoids. And so that was nice, and we could do that. And we found that the area was equal to, what was it, h over 2? And then we had y0 plus 2y1 plus 2y2 dot 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 plus 2yn minus 1 plus yn, because we remembered, number one, that the volume of, that the area of a trapezoid was 1/2 the sum of the bases times the height. And then we realized if we were adding up a whole bunch of trapezoids, that kind of what I would call this inside base, as it were, was double counted. Once for this trapezoid and a second time for that trapezoid, and that's where those 2's come from. Okay? So that was a good tool to use when we're finding the area under the curve. We were also able to use it when we were trying to find the area under the curve using a table. That was the example that we did last week. And then we had one more that we used, which was Simpson's rule. And I honestly don't know what the little shapes look like for Simpson's rule, but the idea is that they're more curved, and so again, they would more closely fit the shape of the curve that we're trying to find the area underneath. And Simpson's rule was h over 3, and then it was kind of this funky pattern of 2's and 4's, and I believe that we had to end with a 4. Is that right? Hang on, Maddie. If I don't write this down right now, I will mess it up. What's up? It will most likely tell you, because here's the thing. By the time we get to the end of chapter 7, there will be no reason for you to use one of these approximation methods to find the area under a curve unless it's a table, unless it is something that we cannot find the antiderivative of, and there will be some things like that. But what will most likely happen is it will either be a table, or the problem will say use Simpson's rule, because they want you to show that you know what it is. So chances are you will be told. And I am thinking that even when you have a table, it will say use the trapezoidal rule to solve this problem. But you need to know what both of those are in case the problem says use Simpson's rule to figure out what the problem is. Okay? All right, so again, that was just review. We went through all of that last week. I'd like to do number 19 just because it talks about the error bounds, which I find tend to be a little wacky. So you may have done it. You may have gone through all of it. I believe it's a journal problem. So we should be able to whip through the beginning. And then I have one more problem that I want to do, and then if we have time left, we'll go over journal questions, and if there are no journal questions, we'll go over the break homework. Okay. All right. So somebody read us number 19, please. Yeah, it wasn't a journal problem. Oh, okay. Well, good. Then I feel less bad about wasting your time. Yeah. Yeah. So Okay, so let's start with that. So we had Simpson's rule on the previous page. And I really feel that when you use Simpson's rule, it's important to actually write it out so that you get the 2's and the 4's correct. The coefficients. So this is going to be h over 3 y0 plus 4y1 plus 2y2 plus 4y3 plus y4. Okay. All right. Sarah. You okay? All right. So remember that h is equal to b minus a over n. And so what's b? What's a? What's n? 4. So what's h? 1. Okay. And then the integrand up here is what we're going to use to figure out what all of the y values are. And you know me, I like a good table. So I think it's probably a good idea to write the x values and the y values. I'm probably going to run out of room there. But where is x0 going to be? -1, because it's going to be equal to a. And if I pop -1 into my integrand here, what am I going to get? 1. Okay. And how about x1? That's going to be equal to 0, because remember, the width of my interval, subinterval, is this h, which is equal to 1. Most problems will have that. Okay. So if I substitute 0 in to my integrand, what do I get for y1? No, 0. Okay. Yeah. Okay. So then x2 will be 1. And when we substitute that in, Maddie, what do we get? -1. Priya, you're up for the next one. x3 will be equal to 2. So what's y3 going to be? You know, graph it, you substituted in. Yeah. So what were you going to say? Oh, okay. So you can do the next one then. x4 is equal to 3. So y4 is going to be what? Is she right? Yep. Sarah says yes. Okay. So now we've got all the values that we're going to need to evaluate the Simpsons, or evaluate the area using Simpson's rule. Okay. We did all the way to 5, or 4 rather. Which is why I like to write it as x3, x4, y3, y4, is to make sure that we've got all the right values. Okay, so when I come down here, my s, I know that h is going to be 1, so that's going to be 1/3. y0 is 1. y1 is 0, y2 is, y3 is, and y4 is 21. Okay, so what do we get? See if you can do it in your head. What'd you get, Sari? Sari gets 12. I hear lots of 12s. I agree as well. Good job. Okay. All right. So everybody good with part A? Practice the formula. Pretty straightforward. All right, on to part B. What does part B ask us? Okay, so the exact value of the integral, that's not too bad, because this is a polynomial. We know how to take the antiderivative of a polynomial. It's just kind of using that inverse power law or the integration power law, which we all need to practice a bit. Okay, so remembering all of our properties of integrals, I can of course break this into two different integrals. I'm just going to treat each term separately. So what's the antiderivative of x to the third going to be? X to the fourth over 4. I take my current exponent, I raise it by 1, I divide it by the new exponent. And remember, you can always check that I could take the derivative of this. I'd bring the 4 down, it would cancel with the 4 in the denominator, and I'd end up with x cubed, right? Okay. How about the antiderivative of 2x? Just going to be x squared, right? Because I would raise the power by 1, divide by the new power, but the 2's are going to cancel. And I'm going to evaluate this from -1 to 3. You got an answer for me, Casey? What do you got? Casey gets 12.5. Is she right? I get, let's see, 3 to the 4th is 81 minus 9 minus a 4th minus 1, right? So this part and this part is going to give me 80 over 4. And this part and this part is going to give me -8. And 80 over 4 is going to give me 20 minus 8. It's going to give me 12. Try it again. The calculator, see it moves. We've discovered. Everybody check though, because I did it in my head. Good. Okay, are we good? All right, so what's the error going to be? There is no error, right? Let's continue with the problem, shall we? So the formula that you would have used to find the error looks like this. And let's talk about that for a minute. Just write it down so that I can point at it and you can make notations. This is new. No, this was in the section that everybody was supposed to read. Okay? Elf, you especially take note because this is going to come back later for you. Yes. Just, yeah. Okay. All right. So we know what B and A are, right? The lower and the upper bounds of our integral. Those are easy. We know what H is, right? The width of our subinterval. So let's talk about this thing down here. This, what is that? We have come across this before. Because it looks stupid if I make 4 hash marks. Okay, so this is the 4th order derivative. Or the 4th derivative. The order could be in parentheses. Okay. So you know that. And it's the 4th derivative of the integrand. And again, at this point in our careers, we can take the derivative of anything. It might not be pretty, you might not like it, you might make mistakes, but you can certainly take the 4th derivative of anything because you are masters. All right? So the other part is what that capital M is. So this whole thing means the maximum value of the absolute value of the 4th derivative on AB. Of the 4th derivative on that interval. Okay. So just intuitively, you know that for this particular problem, this is equal to 0 because the answer that you got for Simpson's rule and the actual value for the integral, the exact value for the integral, are identical. Like at however many decimal places you want to go, they're both 12. Okay? But then we've got to go to part C. And what does part C say? Okay, so this is our error bound formula. It's a bound because, as you notice, it has a less than or equals than sign in it. Okay, as opposed to saying it is this, it's giving you an upper limit to what the error would be because you are using the maximum value that you would get of the 4th derivative of the integrand on that interval. Again, that maximum value part, Alf, you need to remember that. Maddie. Exactly. Exactly. So let's go back. So hang on. So let's go back to f of x. What's f of x equal to? Okay. All right, hang on. Let's just do it out for a moment. And then, because in part D, we can make a statement about that. All right, so what's the first derivative going to be? 3x squared minus 2, yes? All right. Sari, what's the second derivative? Good. Rebecca, what's the third derivative? Zoe, what's the fourth derivative? 0, okay? Which is what Zoe said because she was doing it in her head. All right, so we know that the maximum value of f, of the fourth derivative of f, is going to be equal to 0 in this case, which means that my error bound, my upper error bound is 0, and you can't have negative error. It doesn't work that way. It's just an error. It's just a difference. So this has to be 0, which means that Simpson's approximation has to give us an exact answer if what? Yes, if you have a less than fourth order polynomial, then the area you get under the curve with Simpson's rule will be exact. So you should write yourself an answer to part D. And then share it with somebody near you to make sure that they think you wrote the right thing. Yes. Yes. Little f of x is the integrand. The lower cases and the capital F's and all that stuff get very confusing, I find. That's what you're supposed to be writing right now, is that general statement. Oh, I'm sorry. I thought D just said. Oh, never mind. Yeah, we did C. And then D is the general statement to make. And then share that general statement with someone near you. It's the error bound, which means it's like the biggest error it's the biggest difference you could have between the exact value and your approximation using Simpson's rule. All right, so write a statement, share it with somebody near you. If you don't know what to write, ask somebody near you. I do. Can you go take it in proctored? Yes, definitely. Okay, well, I'll look at it in between and see if I need to like give it to you in pages, but I think it's just like 2 sides, in which case I think you'll probably be able to finish it. All right, We got it? Everybody write something down? Everybody check what they wrote down with somebody else? Okay. All right, then one more problem that is, I guess, a bit more practical. So let's do page 317, number 30. If somebody would read it for us, please. Okay, so they give you something that looks like this. And you've got y6, y5, y4, y3, y2, y1, y0. And I'm not going to copy it down, but they give you what all those y values are, correct? Okay. And we need to find the area of this part. And I always had a little trouble visualizing this problem. So here's the thing that I drew, okay, which is this cross-sectional area. So this is this thing. But then what it is it extends back, okay, and this length, I don't know as I ever gave it a value, or it's the length of the tank. We shall call it capital L, just to give it a letter, okay? No, L goes into the board, which is why. Okay. The distance from y0 to y6 is 6 feet. Because they tell you, among other things, that the spacing between each of the y values is 1 foot, which tells us that h is 1 foot. Okay. So let's think about this for a minute. I know that the weight that has to be in my tank is what? Is it only 500? Okay. Has to be 5,000 pounds. Hang on. Everything has a weight. It is very weird, but everything has a weight. And I would guess, although I am not positive, but I would guess that when you're dealing with how much energy you're going to get out of a fuel, that the weight is more important than the volume. Because depending on what form it's in, you could have more or less particles for a given volume, whether it's a gas or a liquid, whereas the weight will give you a measure of the number of particles that are there that are able to make the chemical reaction that will generate the energy. Okay. So how am I gonna, what am I gonna do? Maddie, what do you think? Okay, I can't quite do that because remember, my American friends, that this is not a mass, right? You don't have to. We're going to fudge it. Okay. But this is not a mass. It's a what? It's a weight. And my AP Physics friends, we know that there is a difference between weight and mass. However, there's absolutely, if we're assuming that everybody's on Earth and everything's pretty close to the surface of the Earth, then we can say, we can make a density expression in which it's weight over volume instead of mass over volume. And that is in fact what they give us when they tell us it's 42 pounds, which is a unit of weight, divided by the volume, which is cubic feet. The whole thing's just stupid anyway. But is he still at Amherst? Who does he have at Amherst? Okay, ask him. I wonder if any of my math teachers are still there. That's all. Although it's been quite a while. No, 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 they came after me, but they've worked with my mom. Yeah, but yes, because my mother works with Froman now and worked with Farina for years. Okay, so now what? Natty made a wonderful observation that I do have this information about, we'll call it density even though it's not, about density and weight, and I want to find the weight, so I could certainly do something here, but what do I need to know? I need to know the volume, right? How do I find volume? What? Yeah, so how do we do volume? So really the volume formula that I want to look at is cross-sectional area times length, which pretty much works for anything. That's the way, and you know that that is the way you would find the volume of a cylinder. It's how you would find the volume of a cube or a rectangular solid. You just don't think about it that way. So a formula like that, as far as I can think of, will work for anything as long as the sides don't change. So like if it tapers or something, it's not going to work. But as long as the cross section at both ends of the length are identical, taking the area of the cross section times the length should work. And that's pretty cool because what I really want is the length. And so how am I going to find the cross-sectional area? I'm going to use Simpson's rule. Why would I use Simpson's rule? Well, it's okay, so because we don't have the y, because we don't have a function, but we have the y values, means that we should use some approximation. But we could use LRAM, RRAM, or MRAM. We could use the trapezoidal rule. We could use Simpson's rule. Why is Simpson's rule probably the best choice here? It's a curve. Okay, a curve is going to give us better. Simpson's rule works better with a curve. Okay. Did we say that? You may have read it, and that may be true. Okay. So let's start by finding that cross-sectional area, and then we'll come back to this. Okay, so everybody got what they need from here? I can lower it if we need other stuff. Really, all that at the top is a picture. Okay. We good? We got what we need? All right, because I'm just going to start on a new slide. So again, I think it's really important to write out Simpson's rule before you substitute into it. So what are we going to have? What is it? It's h over 3 times that went by so fast. Okay, we will finish this problem up tomorrow because it really won't take that long, and then we will start chapter 7 tomorrow, so please make sure you read 7.1.